In this series of videos I'm attempting to repair and restore this HP9845B vintage computer. So far in this series I've been through the machine, found quite a few faults and I've put those right, and found faults in the processor boards, found a fault in the keyboard, found a fault in the power supply, and been through, now got it to the point where it does actually start booting up to the welcome screen on the CRT. As you can see, I've removed the CRT and I am currently working on the printer. This machine has an integral thermal printer. It's quite a complex printer, and the system is driven through a number of boards. We have the main control board, which is the one you can see here on the riser. We've then got the driver board, which is the one that's really the right hand riser leg for the CRT, and then there's another board inside the print head. Quite a complex print head. It's full width print head. I think it's got 560 heating elements on it, and it's quite a complex task to drive it, which is what all the electronics is for. Now, when I first started looking at the printer, which is what I'm now trying to fix, it didn't really do anything at all. When I tried to send characters to the printer to print, it did nothing, didn't respond at all. And the first thing I found, and this is something I think I pointed out in the second video in this series, is there was definite signs that this large smoothing cap, and this is fitted normally on the driver board between the plus 13 volt rail and the minus 17 volt rail, and its main job is to remove the large back EMF spikes from the large stepper motor when it's being driven. But this was open circuit. As I was saying in the second video in this series, we found this mark on one of the pins on the capacitor, and it's usually indicative when you see something like that that the capacitor is open circuit. And when I took this out, sure enough, I hope you can see this pin is actually loose. It's not attached to anything internally, so I'm not bending it, it's just loose. And the third pin on this, by the way, is just a mounting pin. It's not electrically connected to anything, it's just to stop this flapping about. So I replaced that. One of the problems you can get when you have a capacitor in this position open circuit is you can get large spikes going through the power supply, and it can do quite a lot of damage to other components. So I've replaced that. I then started looking at other faults on the driver board, and I initially started going through this using the scope and just really doing a little bit of probing around, trying to find out where the control signals were getting lost and why it was doing nothing at all. Most devices in this machine are really accessed through a set of call them registers within each subsystem, but they can be anything from single bit pins to latch data or something like that, through to fully fledged actual registers. In the printer, all four are really used for telling the printer system that there is data. In fact, only one of them's for that. The other one that's in use is to allow the interrupt system to operate the way it's supposed to. But the data wasn't getting through. The decoding for this particular board wasn't working, and that came down to a group of faulty ICs. These were all in the decoder circuit, and they were all completely non-functional. So I've replaced those, and that then had the printer starting to come to life. It still wouldn't work properly. So once I'd replaced those, I attached the logic analyzer, and I showed this in a previous video, but I was getting garbage out of the test connector. The test connector gives us access to various control signals, and it also gives us access to the inverted address bus, and that's the internal address bus. This board is driven through its own microprocessor. It's a HP specific processor, usually called a Nanoprocessor, and the test connector connects to the inverted address bus from that processor, and it also connects to the non-inverted data outputs from the processor, along with some control signals. So what we should see on the data bus is the output from the, amongst other things, the output from the ROM. This has two ROMs. One's the system ROM to run the printer subsystem, and the other one is the character generator ROM that contains the character set that the printer uses. But what we should have been seeing is the data coming out of the system ROM, the printer system ROM. But what I was getting was just nonsense, even taking into account the fact that the data's in reverse order. What I was getting was just apparently garbage coming out of the ROM, so it looked like the ROM had failed. And just move the machine a bit so you can see the ROM. So the ROM is the one at the top, I'm not sure if you can see it or not, it's the one at the top at the rear of the board. It's this device. And I looked at it under a microscope. It was originally soldered to the board, but under a microscope I could see that several of the pins or legs from the IC were cracked. So I desoldered it and removed it, and I think 3 of the pins, they were still just hanging on to the chip, but they weren't making electrical contact. I'm not quite sure how they were hanging on at all. When you touch them, they just kind of flapped about. So you can perhaps see I've resoldered those, and I assume that was what the fault was. Put a socket into the board, refitted it, and I was still getting garbage. Different garbage this time, but still nonsense. So decided that I'd try and read this. Now it is a 3 supply ROM, and it has latches on the address lines, so it uses -5 volts, -12 volts and +5 volts. So what I did was make up an adapter so I could really fool the programmer I have, which wouldn't support that type of device, into thinking this was a 2364 ROM, the same type that we were looking at on the main system ROM boards in the 9845. And when I did this, I could actually read the ROM contents, and I could read them consistently. They were the same every time. Now it doesn't mean the ROM was working, but it's usually a fairly good sign that it's largely intact. But more importantly, the data I was then getting wasn't the same I was seeing through the test connector. And I had also tried attaching the logic analyzer directly to the ROM with a test clip, and I was getting the same garbage. So something very strange was going on with this. So I started looking at this and realized that the problem could well be with the Nanoprocessor itself, which is this large white 40-pin device at the back. And they are extremely rare and hard to get hold of, so I was hoping that wasn't the case. But there's nothing else really attached to it. I removed the buffer chip that sits between the Nanoprocessor data bus and the rest of the system just to isolate it, but I was still getting garbage. So I started fearing the worst, and that the Nanoprocessor had failed. One of the things with the Nanoprocessor, if you look at its spec sheet, it doesn't have a reset pin, and the reset is affected by the order in which you power up the device. There are a number of power rails. One of the power rails is also the backgate voltage, which is set specifically for each particular device, and it may vary. So you'll see there's a voltage written on each of the Nanoprocessors. So I checked that was correct, and it was indeed correct. The order and the sequence in which the power supplies were coming up was also correct, so it wasn't that. But one thing I noticed while I was checking that was the clock pulse going into the Nanoprocessor was well outside spec. And when I say outside spec, I mean the rise time was way too slow. And because of the way the Nanoprocessor works internally, the rise time of the clock has to be fairly fast, has to be very fast. If it's too slow, you'll get a skew in what's going on internally within the device, and certain parts of it will respond to the clock edge before other parts, and it kind of scrambles what it does. And in this case, I noticed that it was driving several of the data pins when it shouldn't have been. It should have been trying to read data from the ROM. Trace this back through, just grab the schematic. You probably can't see much of this, but what we have on the clock output, which is up here, is there's a pull-up resistor, and that goes up to the +12 volt rail, and then this diode is to clamp that line to 5 volts to make sure it doesn't go too high, and that gives it a very fast rise time, and the rise time was about 2 microseconds, which on a 4 megahertz clock means that it never goes up to full value. It was only going up to about 1.5 volts. So it wasn't really clocking the nanoprocessor, and I found that this resistor, 680 ohm resistor, was open circuit. So I replaced that, and then the nanoprocessor started coming to life, and it started reading the data from the ROM. Printer still wouldn't print. It was doing strange things. I'll just demonstrate what it then started doing. So we'll power up the HP, and I'm going to just type in a command to send all the data through to the printer. Okay, and now we'll try and send 1 character through to the printer. So notice it hasn't printed a character, it just prints 8 of these lines and feeds out a lot of paper. It does that whenever you try and type in. So I'll power this back off. So needless to say, this was going to be a bit of a pain to sort out, so the first thing I did was to remove the drive belt so I wouldn't waste all the paper. And then I started looking at this more carefully. The next thing I found was that the sensor, paper sensor on the printer, the output was open circuit, so it was never sensing paper. I don't believe that's anything to do with the fault I was seeing, it's just something I found along the way, but I did correct it. I fitted a different type of sensor, and it is now responding to paper. And it did appear to be searching for a hole in the paper. And in fact, if while it was driving the paper out, you interrupted the slot in this and then removed that interruption, it stopped the paper from being fed, like it had found something it was looking for. So it's almost like it was looking for perforated paper, but I'm pretty sure this particular printer is supposed to work with plain paper. So I don't believe that's what the problem was, but I fixed that anyway. But even though it now can see the paper, it made no difference. So it was getting a bit confusing. I decided to write a few test programs, so I made up a test ROM in the same way I did with the main boards on the HP. Wrote some test code. So in this case I did use an EEPROM with an internal address latch, and when I started doing that I was getting some fairly odd behaviour. Now early on I thought it might be an issue with the RAM chips on this board. There are 2 4-bit RAM chips to give it 8 bits by 256 bits of RAM. So as you can see, I removed those. They're now in sockets, and one at a time, which is important, and I'll come back to why that was important later on. Remove them one at a time, put them into a tester I've got that claims to test them, and it tested them fine. I ran them through probably 5 or 10 times each, and they both passed with flying colours, and I obviously put them back into their respective sockets. Moved on and started looking for other causes, and I couldn't really find anything definitive anywhere else. And looking at the data coming out of the test connector on the logic analyzer, it was looking very strange, and we'll look at the logic analyzer in a minute. But despite writing some test programs, it was fairly apparent it was going to be quite complex to sort this out. So I then branched off and decided to bite the bullet and do something I've wanted to do for a long time, which is to write a simulator for the nanoprocessor. Now just to clarify that tool, I showed the tool in a separate series of videos. There does seem to be a bit of confusion over what it's for. I'm not trying to emulate the nanoprocessor so I can replace it, and I'm not trying to emulate the outcome of the nanoprocessor, so I'm not trying to put something together that will take the binary file and duplicate or emulate the output. What I'm trying to do, what I did, was create a tool that simulates the internal workings of the nanoprocessor, and also tacked onto it the internal working of certain circuits within the printer. That's a very different thing to a normal emulator, which tends to do a high level emulation of output. So anyway, we've got this issue now where it's just feeding out the paper. So I'll have a quick look at the logic analyzer, because what I did as soon as the tool was ready, I'd created, was run them both side by side. So we ran the software tool and the hardware and compared what the hardware was doing by looking at the output of the logic analyzer and comparing that to what the software tool was doing. And very quickly they started to diverge and go in different directions. And I was pretty sure it wasn't because I'd made a mistake in the software tool. I'm pretty sure it was something to do with the hardware. So I'll move the camera, we'll look at the logic analyzer, and I'll show you what I found. So we're looking at the logic analyzer here. I've got the address set on the trigger to 086. If you want to see why it's 086, if you go and have a look at the videos I posted on the software tool, you'll realise why that's set to this address. But in essence, it's the point at which data starts to be read in from the HP in response to us sending data to the printer system. So we'll arm the analyzer. I've got the machine running. I'll try and enter a value, single character. You can hear the paper being fed out. And it's still doing the same thing it was doing before. I'll turn the machine off so you can hear me a bit better. The part of the code we're looking at is here. So we're looking at this address 0086, and let's pull the light across, hopefully you can see this a bit better. So at 0086 we'll see a ROM value of 73. And indeed we do see a ROM value of 73. So at 0086 you can see here, this is the data value we're seeing from the ROM. It is indeed 73. So what it's doing at this point is reading in a data value from the host machine. But what it's going to do is output the data to the RAM, and then it's going to read from the RAM. So if we go to address 89. Okay, so you can see here that at address 89, which is here, we're reading in a value from the ROM of 45, and that's correct. You can see that being read in here. The data that it's reading in from this device then follows on and is put onto the data bus. And you can see that value here is D0, but that is incorrect. When the system initializes, and again if you go back and look at the software tool videos, the initialization part of the code writes 0 values for all the addresses in the line buffer in RAM to a value of 0. It actually sets them to 255, but because they're inverted when the Nano reads them in, they should all read at this point as 0, because this is attached, our logic analyzer is attached directly to the Nano pins. So this should be 00, not D0. And that's a little bit strange. So there's obviously something wrong going on here. And each of the locations in the RAM, each byte in the buffer, it's a 160 byte buffer. The maximum number of characters in each line is 80, and there are 2 bytes for each character it wants to print. The first value is the value of the character, and the second byte in the pair are the specific attributes of the particular character. So when the HP wants to change the attributes that are going to be assigned to incoming characters, it writes a single character that's interpreted as a control character by the printer. That value is stored, and then any incoming characters are given that attribute until such time as the HP changes it again, so it doesn't send the attribute with every single character. But this value, it's reading it in to see if this particular location in RAM is available, and this should not be D0. So what's actually happening here is it's reading in the wrong values from RAM, and as I said, I did test the RAM to see if it was working, and the tester I used said it was. Unfortunately, I don't currently have any replacements. What I'm going to do is swap the two RAM chips over. Like I said earlier, I put them back in their original locations, but if we swap them over, we'll get 0D instead of D0, and that should actually enable the machine to do something. It won't behave as it should, but it should do something different from what it's doing now. And then if we need to, we can see if we are then getting different value out of the RAM. It looks like one of the RAM chips is failing, but we'll swap it over and see what it does. So I've swapped the two RAM chips over. We'll boot this back up. I'll enter the command to send data through to the printer. And we'll try and send a character and see what happens. It has indeed printed the correct character. I can't scroll the paper out, I don't have the paper feed switch plugged in. I'll try and send a few more characters. It is printing the correct characters. I'll try sending a few more. And it is sending the data through to the printer. Okay, so I'll turn this back off. So it looks like our problem that's remaining is just one of the RAM chips is faulty. So despite them testing good, chances are one's just behaving a bit oddly or just running a bit too slow for this particular machine. And this is something I've pointed out previously on other videos, that just because you see signals coming out of a device, it doesn't necessarily mean that it's working. It can still be faulty, and it's worth looking at the quality of the signals, not just the fact that they're present. So we're now getting a lot closer to this working. I'm a bit concerned that it only seems to be able to print using the first print head. It's not doing anything beyond that. That could be something to do with the faulty RAM, or it might be that the print head itself has failed. The print head drivers are blocks, and each one provides a particular block of data, and it might be we've got a failure somewhere in the print head, but it could even just be that because we aren't able to read the entire buffer from RAM, that that's where the problem lies. But first thing to do is get the RAM chips changed. Don't have any spare at the moment. I've got some on order. Whether or not I replace those in this video depends on when I decide to post the video, but we are now one step closer to having this machine up and running. So before we finish this video, I just thought I'd show you the difference on the logic analyzer now that we are seeing some output. Incidentally, one of the tests I did with the software tool was to make a small modification so that all the data coming out of it was D0, and then it started doing exactly the same thing as the hardware printer. So it was a fairly good tool to use, and this entire fault, which would have been very difficult to track down otherwise, took less than 20 minutes to track down using the combination of the logic analyzer and the software tool. And using them side by side and seeing where they went separate ways gives a very good indication as to where the fault lies. So what I'll do now is we'll rearm the analyzer. I'll send the character through to the printer. That has indeed triggered, and if you recall, at address 89 we were getting D0. The 0D is the value coming from the host machine, and that's the command telling the printer to print the character. And if we keep scrolling across, we'll go to 89, and after 89, if you remember, we were getting 45, which was the ROM character, and then we were getting D0, and we're now getting 00, which is the correct value. So it is looking like we do have a failed or partly failed RAM chip. Now it is still possible the fault is somewhere else in the system, and the RAM chips are just more able to deal with that issue this way around, but most likely it's a failed RAM chip, so that's the next thing for me to try.